everyone. I'm Hari Prasad from AADS department, third year, and other two members are the Akash Kumariam. He is also a third year student from AADS, and Aravind R. He is also a third department. We three worked together and built the project. It is named as Hear the Words, an AI predictor for lyric intelligibility. Let me explain about this project while we move on through the PPT. And we did this project under the guidance of three men. Dr. Gauri Ganesha, Dr. Jayanti ma'am, and Mrs. Varlakshmi ma'am. Okay, let me explain about the project. Firstly, let us see the agenda. What are all the mottos we are going to move through this PPT? First one is the introduction. Then we have to state the problem of the project. Then we have to show the scope of the project. Then we say about the methodology we implemented. Then we will be showing the outputs, result, and the test cases used in this project. And finally, conclusions and what are all the future works we doing and the references. Okay, firstly, let us speak about the introduction. Lyric intelligibility prediction is that predicting the accuracy of the lyrics heard in a song. Imagine here you are hearing a song, you can't hear some of the lyrics correct, right? If in case of ours itself we are facing this problem means, then think about the people with this hearing loss. They will be struggling to find lyrics of the song. So our project's aim is to predict the accuracy score of the lyrics heard in a song. Then the accuracy score will be by sound engineers and the engineers who are working in the hearing aid manufacturing industry modify the song according to the people with hearing disability and modify the song according to them so that the people with hearing disability might also enjoy the music. So this is our project's motto. Okay, our project's context that over 430 million people worldwide suffer from disabling hearing loss. The issue that the current assistive devices like hearing aids are optimized for speech but not for the lyrics in music. That is the main issue. Lyrics in songs are often unintelligible due to the background instrumental noise. It is the main problem that the background music is interrupting the lyrics so that it is difficult to implement that uh, speech metric in lyrics of the song. And the lyrics of the song are not like speech. It is not like normal. It has some tunings, some changes in voice, some vibrations, etc. Okay, the solution is to novel and AI framework uh, developed for the ICASSP 2020 guidance of yes, our project's problem statement was derived from the ICASSP 2020 cadence or challenge. Our goal is to automatically predict the word correct. It is the term of the accuracy score of the lyrics in the song. That is how well the lyrics in the song are mainly if we want to say to the people with. Next we have to see the statement of the problem. There is a measurement gap. Unlike speech, there are no reliable metrics to measure lyric clarity in music. They said already there are many models to clearly predict the speech, but not in music lyrics. That is the problem. We are giving into that. The key challenges are signal. This is in terms of the singer. Wide pitch range, sustained novels, and vibrato. They make singing harder to analyze than speech. Then noise. Instruments are structured noise. This noise occurs from the instruments like background music. It interrupts the lyrics. Okay. Then the listener. This is in terms of us or the people with hearing loss. So they can't perceive the lyrics easily and understand it. Okay. Then in terms of production also there will be loss in the song. Like adding reverb and compression to reduce the size of the music file may result in low accuracy of the lyrics. Then we have to see the scope of the project. Our objective is to develop a robust benchmark tool to predict lyric intelligibility scores, which lies between 0 and 1. And our target audience are the researchers in audio tech, hearing aid manufacturers, and the MIR engineers. You may be thinking that our target audience is the people with hearing loss, but not that. Our goal is to produce an accuracy score which will be useful for these engineers. Then these engineers will modify the for the stability people. So the target audience for the engineers would be the hearing loss people. For us, it is the engineer itself. Deliverables. We are delivering a three-stage AI pipeline: is separation, extraction, fusion, and then a predictive regression model, that is XGBoost model. Then validation on the cadence or clip-on dataset which they have provided. And let us talk about the inclusions and exclusions of our project. Inclusions are the music source separation, psychoacoustic modeling, linguistic analysis, and fusion. For MSS, we are isolating vocals using HTDMux. For psychoacoustic modeling, we are using singing adapted HASP metric. Linguistic analysis, we are using fine-tuned whisper ASR model. Then we will be using fusion or as a XGBoost regression model. And what are the exclusions? We are not using real-time processing. The focus is on accuracy and not latency. Then we are not using non-Western music genre. Only using Western music like pop music, rock music. Example, you can say the Believers song, famous Believers song, the Imagine Dragons. Then severe or profound hearing loss. The focus is on not for severe or profound hearing. It is for mild and mid-level hearing loss. Then we are using data set provided by the cadence. That is cadence or clip-on data. Contains about 3,500 to 5,000 segments totally. The limitations are the separation artifacts and genre bias. And then methodology means the vocal isolation. First, we will be separating the vocals of the song using demux. Then we will be dual path feature extraction. First, using the isolated vocal mix and listeners audio, and we will be computing the hash rate. In path B, content. Transcribe, we are with transcribe the vocals and calculate the linguist clarity. Then in signal, we have to extract the acoustic feature, pitch, energy, spectral use. And finally, we have to use the model using XGBoost. This is the architecture diagram of our project, and this is the use case diagram of the project. You can see the uploading data set, then process it, then calibrate model, then we are displaying the result. This is the design class diagram of our project. Then this is the sequence diagram of the project. Uploading dataset, separating vocals, extracting features, predicting intelligibility, and uh, printing the score. This is the sequence diagram. And we are using the algorithms like HTDMux, OpenAI Whisper, and HASP v2, then XGBoost model. Software, hardware, and software used in this project are software of Python 3.8 plus language, then deep learning, PyTorch, audio clarity, is Libroza for acoustic features, and PyXLT as ML, XGBoost, and scikit-learn we are using hardware. We'll be using GPU like NVIDIA GPU, then storage sufficient for sharing of model, word error, data not the test cases, and all of us of conclusion perform. Any question? Thank you so much.